Okay, this is the Geometry Semester 2 exam review. For question number 1, it says, which description does not guarantee the trapezoid is isosceles? An isosceles trapezoid would look like this. Where we have two congruent legs and then therefore two congruent bases, and then the diagonals would be congruent to each other as well. But that doesn't guarantee that the bases, which are the top and the bottom, will also be congruent. So the answer is B, congruent bases. For number 2, it says the radius of circle O is 22 and OC equals 11. Find AB, round to the nearest tenth if necessary. OC is 11, the radius is 22, and we want to find AB, that whole thing. So what I'm going to do is I'm going to use my right triangle. I'm going to find X, which is actually from C to B, and then the distance from A to C is the same. So I'm going to use Pythagorean theorem. X squared plus 11 squared equals 22 squared. So x squared plus 121 equals 464, I think. Then we're going to subtract. We get x squared equals 343. Take the square root of that, and x then equals approximately 19.1. Well, that's x. We want, that's the distance from C to B, we want the distance from A to B, so multiply times 2, and you get segment AB then would equal 38.2, or approximately that distance. For number 3, it says find the area of the figure. We have a triangle. The area of a triangle is represented as 1/2 base times height, and we're given the base and the height. You always want to identify what you have. The base is 19, the height is 7, and you just substitute into the formula. Area equals 1/2 19 times 7, which is 66.5 yards squared. For problem 4, you have to plot your points first. We've got point A is -3, -3. Point B is -6, 2. And point C is -1, -3. And what I would do is kind of connect the dots that you have so far. This is C. We've got AB, we've got AC. I want to add another point so that I have a parallelogram, and I would put it right here. That's point D. And D is at -4, 2. Alright, number 5 might look a little complicated. It's just a different way of writing a set of ordered pairs. So it says triangle DEF with vertex matrix, and this is a triangle. It's just really, this is an ordered pair, this is an ordered pair, and this is an ordered pair. So I start out with a point at 3, -2, we'll call that D. We've got a point E at 4, -3, and a point F at -2, 6. And we want to translate, it says 7 units to the left. Things that are going left and right are your x-axis, and things that are going up and down are your y-axis. So we're going to change the x-coordinate and the y-coordinate. So D prime then, if I go take 3 and I go 7 units left, that's 3 minus 7, or negative 4. And I take negative 2 and go up 8, so I take negative 2 and add 8. That's going to be 6, so that would be D prime. E prime would be 4 minus 7, which is negative 3, and negative 3 plus 8 would be 5. And F prime then would be negative 2 minus 7 is negative 9, and 6 plus 8 is 14. So those are my ordered pairs. Then for number 6, it says find the surface area of the pyramid. We have to have a formula for that. I've got surface area is the lateral area, which is around the sides, plus the area of the base. The lateral area is 1/2 the slant height times the perimeter. And since our base is a square, I'm going to say S squared, or side squared, for our base. And then I need to know what things I have. Okay, my slant height is 8 feet. The perimeter is the distance around the base. Each side is 5 feet, and there are 4 sides, so the perimeter is 20. And my S is my sides, which are, again, side squared is 5. The side is 5. And I can substitute. So now I have 1/2 times 8 times 20 for the perimeter, plus S squared, 5 squared is 25. And I can simplify that. That's going, if I multiply and add, I get 105 feet squared. Okay. Number 7, it's kind of a tricky one. They're really asking, what is the measure of this angle here? And I have a circle which is 360 degrees around, and this is divided up into 10 sectors. 360 divided by 10 is 36 degrees. So each sector is 36 degrees. If you'll think of taking one of those sectors and cutting it in half, that's what each of the letters does. So basically I've got this many sectors, and each of them are half of the 36. So I'm going to take my 36 degrees divided by 2, because I've taken each sector and cut it in half with the letter that's in it. That's 18 degrees. And I have 1, 2, 3, 4, 5. I'm going to back up just a little bit. Take one away. I have 1, 2, 3, 4 18-degree pieces. So I'm going to take 18 times 4. And that's 72 degrees. So it's 72 degrees from the letter A to the letter C. Now number 8, this one says, a cylinder A has a radius of 1 meter and height of 4 meters. Cylinder B has a radius of 2 meters and a height of 4 meters. Find the ratio of the volume of cylinder A to the volume of cylinder B. Well, we want volume formula. Volume of a cylinder is pi times radius squared times the height. We have the radius and the height for cylinder A, and the radius and the height for cylinder B. The volume for cylinder A is pi times the radius squared. Radius is 1 times the height is 4, and that's going to simplify to 4 pi is the volume. For the volume of cylinder B, we're again going to have pi, but this time the radius is 2 squared times 4. This is going to be 16 pi, and it's asking for the ratio of the two. So I just compare them and reduce that ratio. That ratio is 1 to 4. Okay, number 9 says find the area of the regular polygon and give the answer to the nearest tenth. So basically we have a hexagon has 6 sides. Looks a little something like this. It is a regular hexagon, so we're going to assume it's a little nicer than that, but we've got a regular hexagon, we have a center, and so we basically have 6 little sectors here. A hexagon, if we go around the center, we know there are 360 degrees in any polygon. We're going to divide that by 6, and that tells me that each central angle is 60 degrees. I'm going to blow up this triangle that we have for our base, and we know that it's 60 degrees here, and it also told us that the radius of this is 5, which would actually be this side. This would be the radius. And so I'm going to find the area that I'm going to find the area of one of these triangles. Area is 1/2 the apothem, which is the height of that little segment there, that little piece of pie, times the perimeter, which is the perimeter of the whole figure. So we need to find A and P. I'm going to take my triangle, I'm going to take half of it. This is 30, 60, and 90 degrees. You can use your trig ratios, or you can use the fact that you have a 30, 60, 90 triangle here, where the side opposite 30 is A, the hypotenuse is represented as 2A, and the height here would be A square root of 3. So we find A, divide by 2, A would equal 5/2, and then 5/2 would go here as well. So the height of this would be 5/2 square root of 3. So I have the apothem, which is my height right here, as 5/2 times the square root of 3. And I have the perimeter. Well, I have this one little piece here that's 5/2. That's 2.5, which makes the entire base, or the bottom of that triangle, 5 units. And there are 6 sides, so that's 30. And now I'm ready to put it in my formula. So I get 1/2 times 5/2 square root of 3 times the perimeter, which is, we said, is 30. And that's going to simplify out to approximately 65 inches squared. Number 10, we have, it says a dodecagon. A dodecagon has 12 sides, and it has a perimeter of 108 centimeters. Instead of writing the whole dodecagon, I'm just going to make our triangle segment, and I just need to know that there are 12 of those. And I'm going to cut that in half. There are 360 degrees in any of the central angles of any polygon. I'm going to divide that by 12, and that tells me that this one is 30 degrees, which is that whole vertex angle. I only want half of that, so I have a 15-degree angle here. I know that the perimeter is 108 degrees, and since there are 12 sides, I'm going to take that 108 divided by 12 just to get one of the sides of the figure. And that's 9.